So when we're factoring, we can start with prime factorization. So we need to be able to factor numbers. And to prime factorize, we can use either a factor tree or any other method that you want. So I have here a fairly big number, 8820, and I'm going to prime factorize this, and I can use a factor tree, and I'll do it up here. So 8820. I can do it any way I want. I can do divide by 4 or divide by 2. Dividing by 2 is probably the easiest, but it's nice to divide by bigger numbers, and then you have two branches that you can factorize. So here I'll just do it 2 times 4 times 4,410. Okay, divide by 2 again. I get 2,205. We know that's divisible by 5. Okay, when we divide that by 5, we know that 5 goes into 2,400 times, into 240 times, so 441 and 441. If I'm not mistaken, I think it's divisible by 3. Okay, so I can divide that by 3, and I end up with 147, okay, which is also divisible by 3, which is 49, and then I have 7 times 7. So I want to go all the way down to the prime numbers, and once I get to my prime numbers, I have fully factored this term. So it becomes 2 times 2 times 3 times 3 times 5 times 7 times 7. Okay, so this is our prime factorization. We could have done it, a few different ways. Some people like to do it in this way. They divide by 2, 4, 4, 1, 0, and it's the same thing. Except this, we end up with all our factors along the outside. And this is I divide by 3, I think, here, and then 147. Divide by 3 again, and then I end up with, okay, so all our factors end up along the outside here. So there's lots of different ways, but we need to be able to factor numbers to be able to break up into prime numbers, and also when we're factoring the trinomials, it's good to know your factor pairs as well. Okay, so here we have, we're making 3 lengths of track. I guess somebody's building a house or something. We have 9-meter tracks for electrical, 10-meter tracks for cable TV, and 45 meters for water. So this must be in a city or along a road. And we're making 3 parallel tracks, and we need to know how far we need to go before these tracks meet up again. So we need them all to have the same endpoint. So basically we're looking for the lowest common multiple. And to do a lowest common multiple, we can just skip count until we get there. Okay, I can go 40, 50, 60, 70, 80. Okay, and we can just skip count to get there. Now there are some other strategies to do this, in that we can do this with the factors. Okay, so 9 factors to 3 times 3, 10 factors into 2 times 5, and 24 factors to 2 times 2 times 3, 2 times 2 times 2 times 3, sorry. I need an extra 2 in there. So 24 factors into 2 times 2 times 2 times 3. And to work out the lowest common multiple, we can just take one of the common factors. So we have 2, 2, one of these 2's, 3, one of these 3's, times 5. So this ends up being 8, 24, 72. 72 times 5 is equal to 360. So 360 meters is going to be the lowest common multiple, or when they are going to meet up again. So that's one way we can do lowest common multiples. We can skip count and just make a list. We can do this method. Another strategy, and it's make sure you understand this strategy if you're going to use it, is I can multiply all three numbers together, and then I can take out all the common factors. So I have 1 common 2, 1 common 3. So if I divide by the common factors of 2, maybe I'll do that in a different color so that you see it's a different strategy. And I divide by the extra factor of 2, the extra factor of 3. Okay, I'll get the same answer. So I end up with 90 times 24 divided by 6. So 90 times 24 divided by 6 gives us our 360 that we're looking for. Okay, so 360 meters is our lowest common multiple. Here we have two neighbors. They have rectangular lots. They're side by side and they share a fence. One guy's got an area of 36 meters squared. This guy's got an area of 45 meters squared. And they share a fence or they share a side length. Well, that means that they must have a common factor. Common factor is a shared side length in our area model. So what is the longest fence that they can share? Or in other words, what is the greatest common factor? So this is a greatest common factor problem versus this one here is a lowest common multiple problem. So we're looking for the longest, the biggest small number. Here we're looking for the biggest, sorry, the lowest, smallest, big number. So that we're looking for the biggest small number here, where we break it up into pieces. Other one is the opposite. So what is the common side length that can be shared along this fence? We're looking for the biggest factor that these share. The biggest divisor is going to be 9. So this side length is going to be 9. That means he's got 5 meters here, and this is going to be 4 meters here. Now it's not drawn proportionally, but gives us the right area. So the greatest common factor is equal to 9. Okay, the fence length is 9 meters. That's the largest fence that they can share to have these same areas.